Alright, HSS Algebra 1 Honors. We're going to be looking at that second CBA so that we can address any of the questions you missed. Alright, so let's take a look at this first question. What is the range of the function graphed on the grid? So one of the things that we discussed in class is the use of our pencil. Okay. Because range goes up and down, we discussed placing our pencil at the origin. We want to find out how low this thing goes. Okay. It seems to stop right there. So we can safely say -3. And we go back to the origin. We want to see how high it goes. And it seems to stop right there at 4. Okay. So we definitely know it goes from -3 to 4. We're talking about y, since it's range. Okay. The fact it's closed circle means we can put equal to, and there you go. Okay, a continuous function. So I'm not going to be exhaustive and talk about why some of these other ones are wrong, but that's definitely a conversation you should explore, and maybe we can explore together. Okay, when we meet to discuss our individual performances. Okay. All right. So again, you have the ability to pause this one. All right. So although there's really different approaches to these problems, we try to keep it simple and really focus on slope intercept form. Okay, which means identifying the slope and the intercept is typically at this level going to be very safe for us to do. Okay, so we can identify immediately the intercept is 128. Okay, the y-intercept. So that's important. The next thing is m, okay, which is the rise over run. So we need 2 points. Okay. And any point involving zeros typically a good point. So this one's going to be 0 and 128. This is going to be 4 and 0. Okay. So for us to set it up, okay, we would basically have which is roughly, okay. So if we apply the finishing touches, we have y equals m x plus b. Okay. In this context, we're using t and v. Okay. And if that's not obvious, we can simply switch these two terms. Okay, so so we're here, and earlier we were right here. Okay. All right. Let's move on to the next one. All right. So once again, they want a function rule. Okay. So there's multiple approaches, but we were looking to exhaust y equals mx plus b. Okay. So one thing we notice is that all these slopes are essentially different. So let's go and explore the slope. So any use of zeros beneficial. Okay, so we have and This one seems pretty convenient here. Okay. So let's simply apply it correctly and let the formula do what it does. y2 minus y1 x2 minus x1 so we have 2.5, which is -3. Okay. So we can pursue this further, but with that alone, we guarantee ourselves that B is going to be the only reasonable choice. Okay. Let's get a good look at number 4. Alright, so once again, we're going to take advantage of our knowledge of slope-intercept form. This assures us that our y-intercept is -2 and our slope is 3, which is the same as 3 over 1. Okay, so this is our rise and run. So let's go and look for a graph that has a y-intercept of -2. Okay, that's not happening. This one, maybe. Okay. This one, maybe. And this one, definitely not. Okay. Now we want a positive slope where we rise 3 and run 1. Okay, so here I've got a negative slope. Okay, so that should be obvious. Here I've got a positive slope, which is most likely going to be the correct answer. So what I investigate further is, if I rise 3 and run 1, do I continue to get points on the line? I do. So this is going to be our answer choice. Alright. Let's go ahead and look at this one. You can pause the video and read it in detail. Alright, this one's a little too far for me for now. Okay. Once again, we're in the same situation where we get to exploit this slope-intercept form. Okay, after thorough reading, we essentially have a slope of 1.5 plus 6, and we can go and substitute and say okay, so we're looking for B, a y-intercept, and if there's a tie or something, we're looking for our, okay, typically that's our slope. In this case, it ends up being a little confusing, so let's simply call that slope, which we'll notice is positive. Okay. So this one looks pretty good. So does this one. This one does not. Neither does this one. Okay, so we've got options A and B. Okay, these two have a possibility. Now the slope. Okay, this is going to be 1.5 over 1, or you can use your equivalent fraction knowledge and call it 3 over 2. Okay. So let's rise 3 and go to the right. So if I'm here, 1, 2, 3, 1, 2, that doesn't work. Let's go to this one. 1, 2, 3, 1, 2. And that one doesn't work. Okay, so of course what I'm applying here is not working, so I've got to look at these graphs a little bit more careful. Okay, so I know for a fact this is the run and this is the rise. So if I look a little closer, I notice that these are not single units, right? It's a triple unit, right? It goes by threes. So let me try that again. Rise 3, run 2, 3. Okay, these are single units, so 3, 2. This one goes a little past, okay? So I'm starting to think it's not this one. If I go up 3 units here and run 2, it seems like this is going to be my correct answer choice. Okay. So that mistake that I was starting with, that might be something that may have affected some of you guys. Okay, I'm just reading the graph wrong. Alright, let's take a look at number 6. Okay, once again, that specialized knowledge is slope-intercept form, y equals mx plus b. So in general we have this. We see that the 6% is going to be our slope and the 340 is our y-intercept. Okay, we can introduce this notation here, f of d. Okay, sum of all of these conversions, this percentage into a decimal would be 0.06 d plus 340. Okay, that's pretty much it. And if you want it to be safe, once again, we can change these two terms. 6%, remember to move the decimal 2 places over. We have our correct answer choice. Alright, let's move on to 7. Okay. So we looked at an example like this, like all of these other ones in class. And our example involved burgers and hot dogs. But basically this right here, alright, we're told represents pies. This one here is cakes. So 10 pies. This is the dependent variable. And we're basically gonna look for the corresponding independent variable. We can multiply both sides of the equation by 4. Subtract 70 to both sides, which gives us, and we can divide everything by -2, which gives us 15 equals C, or 15 cakes. Okay, let's keep marching forward. Okay, once again you can pause. Take a look at this one. Okay. So function, not a function. Okay. I guess I can introduce here a vertical line, which is equivalent to your pencil. Okay. You run the vertical line test all throughout this graph. You move it from left to right, and you look to see if you hit the graph at more than one place for a particular x. If it fails the vertical line test, it's not a function here, would pass it, so we're good here. In this case, you're looking for something that violates our definition for a function, which is every x has exactly one y. Okay, that's not the case. Plus, it is the equation of a line, so you're safe in this context. Now here we have an x that's been assigned a 1, and that same 1 has been assigned a -1. So this x has two y's. Okay, it does not have exactly one y, so that's not a function. This, right, once again, every x has exactly one y. That's your definition for a function. This x has this y, this same x has another y, so it fails. Okay. Alright, let's get to 9, take a look at this one. Okay, so there's the initial reading, the important graph, and specifically here they want us to describe the domain in range. Okay, so we definitely looked at something like this in class. So when it comes to the domain, we're looking for x values. And we can see that it runs from 0, doesn't go past 0, so from 0 to 50. Closed circle allows us to put equal. Same thing here. Okay. As far as the range, which is in reference to our dependent variable y, we see that it's between 0 and 100. Same thing with the closed circles. Okay. So this is sufficient. If they articulated they wanted it spelled out in plain English, you can just read this inequality, okay? The domain is all x values that are greater than or equal to 0, but less than or equal to 50. The range is all the y values that are greater than or equal to 0, but less than or equal to 100. Okay? Alright, let's go and jump to 10. Alright, so we discuss these kinds of problems. This is clearly substitution of 7 in for x, our independent variable. So let's go and do that. P of 7 equals 2 times 13. Okay. We also established that anytime you substitute, it's an excellent habit to introduce parentheses. Okay, so anybody reading can clearly identify what just happened. And we now perform the math, PEMDAS. Which is going to give us 36. 7215 is 87. Okay. Let's continue forward to 11. Alright, so after reading this, I think most of you guys would reason that the domain is a set of all x such that what? X is greater than or equal to 9, less than or equal to 13. Okay. Which is relatively reasonable. Okay. Now, once you look at the context, right, which is your critical reading, not necessarily your math, but your reading, you would allow yourself to reason that this is not a continuous function as much as it is a discrete y, because these are subscriptions, right? You're not going to have half a magazine subscription. So more appropriate would have been this description of the domain. Okay. So then when looking at the range, okay, we would basically plug these in, substitute these values in here. Okay, so we're going to go going to pause here to save some time on the video. Alright, so this is essentially our list for the range. So let's go ahead and summarize it. So if you treated this continuously, worst case scenario is you lose a minimal point here or there, but you're on point as long as you can appreciate this context and why we would adjust from continuous to discrete. Okay, so let's take a look at this last one. Okay, so here they want us to write a rule to describe the function. Okay, specifically for this context. Alright. So once again, we're exploiting our knowledge of the slope-intercept formula. More specifically here would be f of x. Okay. So again, there's different approaches to this, but I want to streamline it so that it's less confusing, especially if you're struggling. So we can call this point 2, point 1, which is going to allow me to say y2 minus y1 over x2 minus x1, which will give me this here. Okay, so I've got my slope. I'm halfway there now. Again, there's different approaches, but the fact that we have a table allows us to notice that as we increase our independent variable by 1, there's a decrease by 7. So if we went backwards, okay, 0, in this case we would expect an increase of 7, 46. Okay, so this here would be my y-intercept. So I've got my b, and I've got f of x equals negative 7x plus 46. Okay. Alright guys, appreciate your time. Catch you in class.